Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello, welcome to Pytorch tutorial series. Today we shall discuss about convolutional neural network, and we shall end our discussion by implementing a convolutional neural network on a real dataset. To implement CNN on Pytorch, we have to import Torch, Torch Vision, torch.nn, torchvision.transforms, torchvision.datasets, and torch.autograd. So let's begin. We have chosen a number of epochs as 10. As I mentioned in a previous video that we can select our batch size to optimize our models. In this case, I am choosing the batch size to be 100 and the learning rate is 0.001. Here we can briefly discuss about the torchvision.transforms function. So torchvision.transforms class has a method called .compose that lets you standardize your dataset. So how it works is you can pass your list of transformations inside the compose method. For example, I have transforms.toTensor. I have also used transforms.normalize. So our normalization constant is for height 0.1307 and for width 0.3081. And of course, we are creating a folder called data where we are keeping our dataset. So this is the fashionableness dataset. Okay, once our loading is done, we can go ahead with loading our data using data loader. And this is the structure of the convolutional neural network. In this convolutional neural network, I'm using two convolutional layers. You might have noticed in the previous video that we can choose the number of convolutional layers and then comes the pooling layer, and after that we can pass it into a multi-layer perceptron, which eventually gives our classifications, or I can say gives the probabilities, which is basically used for classification. So in the first convolutional layer, I have 32 output channels, one input channel. Kernel size is 5, which means there are 5 filters. The stride is 1. You might remember that we can downsample in two ways. One is strided convolution and the other one is with using padding and max pooling. So here I am not using strided, I am using pooling for downsampling. So the padding is 2 by 2, so it adds 2 layers of zeros on each sides, as in on all the 4 sides. The activation function is relu, and I'm using max pool 2D. You might remember that the pooling layer can be implemented using two functions, max pool 2D and average pool 2D. Here I'm using max pool 2D, and the stride is 2 so that I can downsample. In the second layer, I have 32 input channels, 64 output channels, as usual 5 filters, stride is 1 and padding is 2. The activation layer is again relu, and max pool 2D is being used for pooling. And then there is a linear function. Like I told you, after convolution and pooling, you have to implement an MLP. For that MLP, I'm using this linear layer. So I have 2 multi-layer perceptrons. One is 7 into 7 into 64 input channels and 1000 output channels, and the second one has 1000 input channels and 10 output channels. In the last one, the output channels is defined as 10 because I have 10 classes. and again I put everything inside the forward pass, and I have to define a backward here so that I can calculate the backward function. You could have also implemented backward directly inside the loop, but here I'm creating a different backward function. I'm keeping it separate, so it's your choice. We create the class of convnet, and all the other structures I have already discussed before. So first you have to instantiate the convnet class. Then criterion is cross entropy loss, which is a good loss function for classification with multiple classes. And the optimizer is Adam, which is a very good optimizer, as we discussed in the previous videos. So let's train our model. Okay, now that our model is done training, we can calculate the accuracy, the test accuracy of our model. To that we are calling model.eval that lets us implement the model on test dataset. And to calculate the accuracy, we are creating this certain for loop, which is similar to the previous videos. We are calculating what is the highest predicted probability level, and we are calculating how many of them are equal to the actual levels, and we are summing them up to calculate how many of them are correct, and we are calculating the percentage. So let's run this code, and the accuracy of our model is, come on, 90.78, which is really good. Thanks for watching.